All right, so something I just thought about is I might actually, while I do this, be allowed to like show you guys little video clips and everything. So today will be a test run. This video has absolutely nothing to do with math or this class. Enjoy.
Yogurt has taught you well. If there's one thing I despise, it is a fair fight. But if I must, then I must. May the best man win. Put her there. The ring! I can't believe you fell for the oldest trick in the book! What a goof! What's with you, man? Come on! You know what? Here, let me give it back to you. Oh! Oh, look at that! You fell for that too! I can't believe it, man! So, Lone Star, now you see that evil will always triumph because good is dumb.
All right, so hopefully you guys enjoy the classic Spaceballs. Which leads me to a riddle. What do flower beds, medical rescues, widget sales, rockets, and cattle pens have in common? The answer? They all arise in situations in which quadratic expressions can help you find answers to your questions. Not so much of a riddle as just a lame introduction in your math book. So as you explore these diverse contexts, you will strengthen your skills in working with quadratic expressions. You will also learn how to change quadratic functions from standard form into vertex form. And actually, that's the important part, that last sentence, learning how to change quadratic functions from standard form into vertex form. So if you think back to the unit problem that I think we kind of skipped, my bad. What the unit problem talks about, and you can read the whole thing on page 280 if you want, but this soccer team, the Bayside High soccer team, just won the championship, and so they're gonna have a fireworks demonstration, and they want to know a couple things. They want to know, sort of based off of some initial data, when should they set the timer, the timing mechanism of the firework to explode? Meaning, like, after how many seconds is it going to be at its max height? And speaking of its max height, what is its max height? Because if you know your max height, then you know how far away people should be seated where they can still get a good view. Um, and as you can see here, it says finally the team wants to know how long the rocket will be in the air. So there's really three things that we're really trying to figure out here, and that is how many seconds until it's going to be at its max height, what is its max height, and then how many seconds till it hits the ground. This is the equation you can see, like there towards the bottom. This is the equation they gave us. And just looking at this equation, we have no idea when the rocket hits the ground or what its max height is or when it's going to be at its max height. And that's the problem with quadratics in standard form, is you can't really tell a whole lot about the way the parabola is going to behave on a graph, just by looking at it. And of course, that is the power of vertex form, because let's just say the standard form converted to this. It doesn't, for the record. I would have simply solved the unit problem for you if I gave you that, so you're not that lucky. But let's just pretend we were given the unit problem in vertex form like this. Well, now we really know the answer to at least two of our questions. We would know that, our vertex was at 8,350, meaning that after 8 seconds of time, we were at our max height, which was 350 feet in the air. So we'd already know to set the timing mechanism to 8 seconds, and that at 350 feet in the air is when they would explode. Now we wouldn't know exactly the path of our firework, meaning it could be any one of these. Like, we know it as a negative, so it's going to be upside down, and it's going to be skinnier than normal, but we don't know exactly. So as far as when it hits the ground, we'd still have a little bit of work to do. But at least just by putting it in vertex form, you can immediately say, hey, at this many seconds, it's at this height. So really, that's where our unit problem is headed, is taking this top function, 160 plus 92t minus 16t squared, and converting it into vertex form. But we're going to take a little side trip first because this function right here is actually kind of difficult to do that for. So we're going to sort of try to build our way up to us solving the problem in a couple activities. So this is an activity that actually was present in Bees, or do Bees Build It Best? I think I gave it to you as a homework assignment. And to be honest, you had to guess and check on your homework in order to get the right answer because you didn't have the skills that you now have. But now you actually should be able to um, solve for exactly for X. So maybe you remember the answer from Unit 1, maybe you don't, it doesn't matter. But we actually want to know if there's this triangle that's 13 by 15 by 14, and I cut it there along its sort of 90 degrees. How long would X be? How exactly would it be split? Now, I hate to give you guys this clue, but because I'm not there, I will tell you that clue to remember that we can call that H. I will give you no more clues, but I think that is enough. So this should take you, I'm guessing, about 15 minutes. Some of you guys, I think, will fly through it. And then our next activity is 309. But plan on this taking about 15 minutes to do. So you guys can get to work on that now. If you finish, just go right into the next activity, page 309. But go ahead and pause me now. All right, so on to page 309, emergency at sea. So this is a very straightforward problem also. I don't think you'd really need any help here. This should again take, I'm guessing, about 15-20 minutes. So again, work on this for 15-20 minutes and then unpause me at that time. Make sure you guys are going over this so everyone really is understanding what's going on. Obviously, again, you can email me if you're still stuck on something or talk to me when I get back, whenever that is. So yeah, go ahead and work on this 15 minutes. Pause me now. All right, so this is a really important activity. Here comes vertex form. So you're going to want to read this, but what we're doing is we're starting with equations in standard form, and we're trying to get it into vertex form. And as it says right here, you're going to need to complete the square because we need that x minus h squared. I will give you a hint on 3 and 4. That gets significantly more difficult. Multiply everything or divide everything by a negative first. You really can't go to complete the square unless you're looking at just an x squared. So I will just spoil that one for you. And right now, say for 3 and 4, you're going to want to multiply everything by a negative at first. I think this is going to be tricky. I think this is going to take the rest of the class period. In fact, that's my expectation. For homework, you're just going to look back at twin primes, spending 20 to 30 minutes on it. And hopefully you're going to finish it or make some progress on it. And that's all I have for today, guys.